Welcome to this course on information theory, coding, and inference. This is an elective course offered to undergraduate and postgraduate students at IIT Hyderabad, and this is under the course codes EE3800 and EE5903. This is the official web page of the course for the 2026 edition. You can find a link to this from my homepage. Go to teaching, and you can find a link to this. So all classes are going to be conducted in person, but recordings of some of the classes are going to be shared on YouTube. Online resources, references, and some details about the evaluation pattern and so on will be updated here. But all other announcements and discussions will be tentatively on Google Classroom. Invites for the Google Classroom will be sent to registered students and will also be shared in the in-person class. If you've not received an invite by, let's say, the second class, please send me an email. So what is information theory about? Information theory, as the name suggests, is about the theory of information. Any problem that involves storing, transmission, or processing information can be studied through the lens of information theory. Historically, information theory has its roots in a paper by Claude Shannon. This paper was titled the A Mathematical Theory of Communication, and I would encourage you to go through this paper. It's a beauty, and essentially captures the basics of everything that will be covered in this course. And information theory has proved to be a valuable tool in several fields, not just data compression and transmission, but also in areas of cryptography, physics, machine learning, computational biology, neuroscience, so on and so forth. In this particular course, we'll focus on 2 or 3 major problems, and I'll also give applications to other problems as well. But the focus of this course will be on data compression and data communication over noisy channels. We'll introduce some measures of information that are relevant to data compression and communication, and also see how it can be applied to various other problems as well. This is a fairly mathematical course. The prerequisites for this course is a strong foundation in probability and random processes. I will expect some knowledge of programming in Python, although not too much. And some knowledge of digital communications will be helpful because we're going to talk a fair bit about communication over noisy channels, but it is not mandatory. I will explain everything that is required for this particular course. This website has a lot of details about assessment and so on. So the main modes of assessment will be through exams. There will be 3 to 4 exams, a few surprise quizzes in class, and a couple of programming assignments which will all be done in Python. So this is a tentative assessment model, and there could be some minor changes. You're free to audit this particular course by registering for the course, but you must secure a regular pass grade if you want a regular AU grade. My contact details are available over here. The class will be conducted in slot R, and the venue for the class is 8221. Here are some primary references. I will also be posting lecture notes, but these are some great references to learn about information theory. We'll take much of the content from these 2 references, Elements of Information Theory by Thomas Cover and Joy Thomas. It's a very elementary book and is a great place to start learning about the basics of information theory. It's a classic textbook. This is a more recent textbook and this is much more advanced. So we'll pick a few topics perhaps from this particular book. This is another book which is also fairly advanced but is also considered a classic. The 4th book gives a slightly different view of information theory. It's also a very introductory book and deals with a lot of applications that we will not cover. I would suggest this for additional reading. There are some other references put up over here. So this is the classic paper that initiated information theory, and a couple of other lecture notes and other material available online. There are also a couple of books to know more about the history of information and about Claude Shannon himself, and you're encouraged to go through these as well. As I said, we'll require a strong foundation in probability and random processes in this course. It will not be possible to cover all of the basics. So I would suggest that you go through your textbook, and here are some good references for probability and random processes. More details about the course will be uploaded, and links will be provided in this website. So please take a look at this often. I'll update the tentative list of topics that we'll be covering, as well as links to class notes and recorded lectures. Hope to see you all in the lecture, and let's learn about information theory.